All right, we're finishing up with mechanisms of epoxide opening. There's two major scenarios for epoxide opening. Epoxide opening. There's scenario one, SC. Strong acid present from the beginning. Well, what does that mean? From the beginning. Wow. Fine. Two. Strong, medium, nucleophile. So we got scenario one. And scenario two, do you agree? Both covered here. Backside attack on the least hindered carbon is the whole story for scenario two. Here's how I remember it. Do you see a charge on this triangle?
No.
When you don't see a charge on the triangle, it's all about attack the least hindered carbon. No charge on triangle. And you're almost done with the mechanism. You got this. And I forgot I have to include something else for you to finish this mechanism. So down here we have O minus. And over there we have SH. I have the enantiomer of the product. I apologize. You'd get this 50%, enantiomer 50%. And I need something for this O minus to pick up a proton. And I'm gonna do it with solvent, which I forgot to add for you. I apologize. I'm gonna add a solvent. You should add it too. HOET, one of the most popular organic solvents. What is that solvent? HOET. That's ethanol. And then because it's solvent, that means there's a whole bunch of it. And you're going to use it as a source for a proton to make your alcohol. If you attack the other carbon, you're not going to get points. You got to attack the least hindered carbon. In this case, secondary versus tertiary, we pick the secondary. Now in the next one, sulfuric acid is the most reactive thing. I hope you feel that. What kind of an acid is sulfuric acid? Strong. What kind of a nucleophile is H2S? Medium. Moderate. Which one sounds like it will react first? Because that's exactly what will happen. The two words strong and moderate tell me which one reacts first. Strong. Please do the acid-base reaction first. You protonate the O. That's the only place you can protonate. And now your triangle will have a charge. You don't talk to me about least hindered carbon now. You talk to me about which carbon helps stabilize a cation better, tertiary or secondary. Tertiary. Attack the carbon that spends more time with a plus charge. In this case, tertiary with H2S. All right. The carbon that spends more time with a plus charge is right there. You're going to get a sulfonium. And I believe we're just going to use the catalyst's partner to protonate, or deprotonate, sorry, the sulfonium. Here's your sulfonium on a dash. That's not a final product. And I know I pointed to the products, and really it's both products should be the enantiomers, right? But they have the sulfur on the right carbon, the correct carbon. And what bases did you make in step 1 that I forgot to draw? Yeah. So I'm going to do it a little backwards. So the O minus is on the right side instead of the left. And come and grab that H. Those arrows are a little heavy. Ends at the H. Ends at the sulfur. Okay. And big concluding statements. These two reactions have, here's a word we don't use enough. I wonder if you can finish it for me.
Isn't the OH the more carbon? Like
On the first one, on the, oops.
the OH.
Oh man, what did I do? Yeah, no, I didn't do anything wrong. I'm sorry. Because this has a charge, we attack the more substituted carbon. Puts the SH on the more substituted carbon. I made a mistake. I copy pasted the product, didn't I? No, I didn't.
So the top one is on the bottom?
Yeah, we're supposed to flip those two. But then, is this one wrong?
Yeah.
They're both wrong.
Yeah.
Yeah, nice job, Dr. Whitaker. Thank you. Sorry. I was throwing shade at myself. I'm allowed, right? Wow, that was a disaster. The tape's been doing that to me. All right, we got SH and we got OH, right? And the S is on the bottom one here. Yeah, and the OH is up here. I think everything matches my mechanism now, right? Mechanisms helped us check our work, and she wouldn't have caught my mistake unless she was following the mechanism. She got a bonus point. Okay.
Yeah, my question is why shouldn't the OH be dash? No way.
As long as they're opposites, you can have wedge dash or dash wedge. My mechanism actually is correct now. But this mechanism, I made the enantiomer, didn't I? Really, this doesn't give this, it gives the enantiomer. But they have the right regioselectivity and stereoselectivity, each one. So I don't mind. These two reactions have blank. You're going to finish that word. No, wrong word to finish. I didn't finish the COMPL word. Are you going to finish it for me? Complementary. So I love poking fun at English, right? That looks a lot like a different word in English, doesn't it? So we got the two products. They're saying, you're looking lovely today. Oh, and so are you. They're complimenting each other, right? Is that what this means? No, that's not what this means. What does complementary mean? You know, one of them puts the nucleophile on the more substituted carbon, and one of them puts it on the less substituted carbon. So there's two possible regioselectivities, and these do each one separately. They complement each other. It's not really the real use of complement there. Okay, so that is the conclusion to the semester. I'm going to do one more, and I'm going to sneak it at the end of this video. You do not have to copy the next part, okay? So I want to do one where there's a strong acid, but it's the nucleophile that does the attack first. And I want to make sure it's in this new example, you see that it's different than this one right here. This one has sulfuric acid. Ours will also have sulfuric acid, but it will be in a second step. So all I need is my molecule from ChemDraw here. And we got our snip. Yeah, it's got a B with it. New page, don't copy any of this. And that won't be a B. Let's do one of our old favorites. 1, KCCH. 2, HOSO3H. So in step 1, which scenario are we talking about? In step 1, are we the strong acid scenario present from the beginning, or are we the strong / medium nucleophile? There is no strong acid present in step 1. There's a strong base, and strong bases and strong acids cannot coexist. So there is no strong acid present in step 1. So you are not in the scenario where acid is talked about. The scenario where acid is talked about is scenario 1, where you make a oxonium and then attack the more substituted carbon. That is the wrong scenario. We're in the scenario where a strong nucleophile opens the epoxide first. SH minus is no different than KCCH. And then step 1, and there's the end of step 1. And in our step 2, I added the acid manually. So we're over here now. Step 1, we'll have the final product when we're done. Bless you. Which carbon is easier to get to, top or bottom? Top. And we're going down here. Step 1 is over right now because there's no protons around to finish this job. So how am I gonna, oh, step 2 is now. And what's in step 2? An acid to protonate your O. Oh, I did it again. I'm on a roll today. I'm on a very consistently bad roll. We attacked the backside on the more substituted carbon in my product that I drew wrongly. The C-triple-N is up here, isn't it? C-triple-C. I'm just having a day, guys, sorry. And then the O, I didn't break this bond here. Did not break this bond. So it's still a wedge. And yeah, this would be a dash, right? Backside of a wedge is a dash. Front, this one never got touched. I hope it's clear it's a wedge. Yeah, that doesn't get clear enough. And where's that thing gonna get its H from? The H2SO4. And finally, we got the product. So on the exam, the product would be there. And we have the wedged O with an H, isopropyl, the what? Quadruple bind, I'm not sure. Octet violation, why not? Okay. Wow. All I got is wow. Says I got an eraser, I can't use it. C-triple-C. That has an H. All right. Step 2. So this was scenario 1 or 2 with a strong nucleophile. I know you want to say it's the strong acid scenario, but guys, the opening of the epoxide happens with the nucleophile. The scenarios are only for opening epoxide. Opening epoxide scenarios? Opening epoxide scenarios, yeah. So if there's no epoxide, you're not talking any scenario. So you do step one. Anytime you're given step one and step two, you must finish step one before you try step two. Okay? And that's the strong nucleophile scenario, which is scenario two. And we followed scenario two right here.
So we either use the strong acid or expose them to protein.
Yes, she correctly surmised the proton for the alcohol always comes from either a strong acid added as a second step here, or from a solvent, like the ethanol, the one I forgot to put here, I needed it, yeah. And you don't have to separate this into steps because this cannot deprotonate this. If you didn't separate these to steps, you've got an acid-base reaction between a strong base and a strong acid. The end of story, your epoxide is still intact. Nothing happened to it. So if you don't put the 1 and the 2 here, you're losing a quarter point on a roadmap. This is a good time to remind you there are no roadmaps on this final. There's a sense of relief in the room. Okay? Yeah. And like I said to a student yesterday, she was a really good student, but she was troubled because she's not acing roadmaps yet. Roadmaps are looking ahead. They're like, you need to get to this level. You're only beginning to think about roadmaps right now. As you build your reaction knowledge, you get better at them. Okay? So no roadmaps on your final, only multiple choice and mechanisms. Don't ask me questions now. You're going to read the study guide and then ask me a lot of questions, either email on the weekend or when I see you Monday. And that is it. And did we have a video going here at all? I didn't think so. We didn't do a video for the mechanism either. It's video free. We're going to do this video over again in the night section. Makes my job easier. I don't have to prepare a different one for them. But I have to remember, activity 3, redone. Which is good because I made so many mistakes on that video. I'm glad the video didn't happen. Oh, I better collect them. So a big one, little one.
Are we done?
Yeah, we're done. Put a fork in it, we're done. Okay. I missed yours. Thank you.
Have a good weekend.
You too. Ready, steady. Okay. Guys, we were recording that video. It's still recording now. Oh man.